Okay, so over here, if I'm trying to draw the derivative, this has a negative slope, a bigger negative, a bigger negative, a huge negative, huge negative. So the slopes look like they do this from the left. As you come in from the right, this looks like a really big positive, smaller positive, smaller positive, smaller positive. So it looks like as you come in from the right, this graph wants to do that. Yeah? Okay. Then if we're looking at this function, I want to draw the derivative. I'm going to find out where the slope is 0 here and here. And then I'm going to walk away from it. So a little bit to the left is a small positive, bigger positive. I'm sorry, it's negative. Let's see, it's a huge negative, smaller negative going to 0, right? And then this is a small negative, bigger negative. Looks like the most negative it ever is right there. So it goes down about here, and then it comes back as the same negative, smaller negative, smaller negative, smaller negative, back to 0. So it's going to turn back this way to 0, even though that's not pretty. It's going to do that. There's going to be an inflection point there, and it comes back this way, right? And then small positive, bigger positive, huge positive. Looks like it does that. Okay? So just to make sure we're clear, this goes this way. There you go. So this inflection point should match up with a minimum in the first derivative. Okay? It's the most negative if you ever go. So then when we come over here, this is 0, bigger, bigger, huge, huge. So it explodes like this. Over here, this is huge positive, and then it looks like it comes back to 0. So it's going to look like that. All right, now we're ready to differentiate functions. For this one, I'm first going to change the form into this with a plus. And then that means that what you're going to get is az to the negative second, bz to the negative first, c. You're adding all those up. So that means if I take the derivative of that thing, so the derivative of az to the negative second plus bz to the negative 1 plus c is just equal to negative 2az to the negative third minus bz to the negative second, and then derivative of constant is 1, so it's this over z cubed minus b over z squared. Then if we want to do this one, so here, before I do anything again, I'm going to change the form. Squared just means that we take this times itself. So we get 1 minus 2q to the negative 1, and then plus q to the negative second. So that derivative is going to be negative 2, negative 1, q to the negative second, minus 2q to the negative third. So that's 2 over q squared minus 2 over q cubed. Say that 5 times fast. Okay, so then I'm going to take all of this and take a screenshot. So copy. So let me add blank. And then I'm going to paste. Okay, so then for h, I'm going to change the form. And that's t to the 1/4 minus 4e to the t. So its derivative. So h prime is just going to be 1/4 t to the negative 3/4 minus 4e to the t. So that's 1 over 4t to the 3/4 minus 4e to the t. For this one, the derivative, well, first I'm going to say, look, the form of this function is stuff divided by stuff. So its derivative, if you allow me to come down here, is low d high low d high minus high d low over low squared. So it's going to be low d high minus high d low over low squared. So you're going to get this. But then notice you've got some embedded derivatives inside of here. So this over here on our scratch paper, if you have to take this derivative, its form is just the product rule. Stuff times stuff. So it's going to be first derivative of the second plus the second derivative of the first. So that's going to be x squared e to the x plus 2x e to the x. And so that means all of this right here is x squared e to the x plus 2x e to the x. So all of that is just that, right? Then if we come over here, I need to do x squared plus e to the x, and its derivative is just 2x plus e to the x. So all of this can just be replaced with 2x plus e to the x. It's multiplied by this over x squared plus e to the x squared. So if all it said was take the derivative, you would be done. If it said take the derivative and simplify, we got to distribute this out. So this is going to be x to the fourth e to the x. And then this one times this one is going to give me 2x cubed e to the x. And move on to this one times this one is x squared e to the 2x. And then this one and this one is 2x e to the 2x. And then this one and this one give me 2x cubed e to the x. Cubed e to the x. And then this one times this one give me negative x squared e to the 2x. Squared e to the 2x. All over x squared plus e to the x squared. Again, you could stop right here if it only says to take the derivative and not to simplify. So what cancels out nicely? This and this. Is that it? Oh, thank goodness. This one and this one cancel out. So you're just left with x to the fourth e to the x plus 2x e to the 2x all over x squared plus e to the x squared. Ew, that was pretty gross. Okay. Then if I take this and copy, we're close to being done. Okay, I said we were close to being done. Let's see. So let me put one more after this. So it looks like I'm going to do this one. So here, y prime, the form of this one as big as it gets. Okay, so the form of this one, I think it's pretty clear. It's just going to be the quotient rule. So it's going to be low d high minus high d low over low squared. So low, high, high, low over low gets squared. So, but then I have to come over at my scratch work and take the derivative of t to the t. So if I take t sine t, it's going to be the first times the derivative of the second plus the second times the derivative of the first. That's going to be what this is. So it's t cosine t plus sine t minus t sine t. And I think it's pretty clear that the derivative of that just equals 1. 1 over 1 plus t squared. So that gives me, if you allow me to distribute, 1 hits this and gives me t cosine t plus sine t. T hits both of these and gives me t squared cosine t plus t sine t. And we have a minus t sine t. So these cancel out beautifully. That's going to give me, okay. So it's all over 1 plus t squared. So that's going to give you, if you allow me to move this over just a little bit. Oh, maybe not. Let me just move this stuff over. Will that work? Oh no. Just this? Okay. Crap. Just trying to move this, please. Thank you. Okay. So that's going to give us t cosine t plus sine t plus t squared cosine t all over 1 plus t squared. If they just said do the derivative without simplifying, you may stop right here at this step. All right. So if I am almost done, let me hit paste. TE to the cotangent of t. So this one's form is stuff times stuff, because I'm really going to see it as this times this. So it's going to be the first derivative of the second plus the second derivative of the first over, oh, that's it. So that's going to be the first, second, first. So derivative cotangent is a negative cosecant squared. But then if I take TE to the t and take its derivative over here on my scratch paper, see it's going to be first derivative second plus second derivative first. That's what this is going to be. So that's cotangent t times TE to the t plus e to the t. And I would leave it just like that. I would stop right there without doing any more simplification because we're both tired. I don't think it's really going to help anything. And then the last one is cosine sine, super easy, or sine cosine. So if I take the derivative of sine cosine, its form is product rule. So it's first derivative of second plus second derivative of first. Cosine is negative sine. Derivative of sine is cosine. So it's going to be negative sine squared plus cosine squared. That's that. So then we come over here. Okay, cool. And let's see. If we're going to do part A, it wants me to find, for this one, P prime at 2. Well, if I find P prime, that's going to be low, D high, or I'm sorry, that's product rule. So since this is product rule, P prime is first derivative of the second plus second derivative of the first. So that means that this p prime at 2 is f of 2, g prime of 2, plus g of 2, f prime of 2. So f at 2 looks like it's 1, 2, 3. G at 2 looks like it's 1, 2. But now I need to approximate the slope of the tangent line. Well, at 2, it looks like f has a derivative of 0. And at 2, it looks like g has a derivative of 2 over 4, or 1/2. So I think you just get 3/2 for that derivative. Q of 7, I think is going to be very similar, so I'll leave that up to you. Okay. I'm going to do A for this one. Oh, it just wants us to find the derivative. So the derivative, the form of this one is product rule. So it's first derivative second plus second derivative of first. So it's just x squared f prime plus f times 2x. So I would probably put that in front because it just looks nicer. And then I guess I would do B for you. So B, if I do y prime, it's going to be low d high minus high d low over low squared. So if this is low high, high low over low squared, it's going to be x squared f prime minus 2x f of x. And you could just leave it like that. Cool. I'll let you do C and D. Then if we come in here, it says, what do these mean? Well, the first one, if you say what that means, this means that sine of 7x over 4x can be made as close to 7/4 as desired, comma, by taking x sufficiently close to 0. And then this one right here says x squared minus 1 over x squared plus 1 can be made as close to 1 as desired by taking x sufficiently large because it's going to infinity. And that should be it. Thank you. And